Hi and welcome to Jawad's Academy. Today's lesson's about the derivative of trigonometric function y equals cos theta. Our last video was about the derivative of sine theta, if you did watch. But today the lesson is about the derivative of y equals cos theta. And the derivative of cos theta is negative sine theta. And the derivative of theta itself is 1. So you can rewrite it as negative sine theta. Now, we have to wonder to why the derivative of cos theta is negative sine theta, which is very good reason to understand why, not just memorizing, right? So here I drew the graph of cos theta right here. And I want to show you why the derivative of cos theta is negative sine theta by drawing the tangent lines through this curve between the turning points and at turning point, then calculating the slope of a tangent at those points that we are drawing, and then we draw the shape to see what kind of shape will it take or will it have. So to pick a point between the two turning points, I can pick up, first of all, I can pick a point right here at this. If I were to start from here, so this is my slope of a tangent would be horizontal at this point, at turning point. Then I can pick a point here, and slope of a tangent to that point would be just touching that point. I know my line is not going to be accurate because I'm not using ruler, but I'm sure you can do a lot better than myself. But the goal is to understand. So we can pick a point here, so we can draw the slope of a tangent, which is horizontal, and then we can pick a point here between the two turning points and at turning point also again. And we should be fine, and we can prove by just calculating the slope of a tangent at these points that the shape will be negative sine theta. So let's see now. We know that the slope of a tangent at the turning point is 0 because it's horizontal. The slope of a horizontal line would be 0. So be right across right here on the x-axis we have a point. In here, at this point, the slope of a tangent, since it's decreases, meaning that the slope is negative, so we have a point below the x-axis, somewhere here. And again, at the turning point, the slope of a tangent is 0, so it's right, we have a point exactly on the x-axis, since it's 0. The slope of at this point here, since it increases, meaning that slope is positive, so we have a point above the x-axis, somewhere here. And then the slope of a tangent, again, it's horizontal at turning point, so we have it's 0, so we're going to put the point right across this point on the x-axis. Now, to connect this point, and you can see that it's a graph of sine function which is reflected on the x-axis. So the equation would be y equals negative sine theta. Now we prove that the derivative of cos theta is negative sine theta. It's very important to understand the reason behind every single step that we do. Then we really understand math. All right, so let's do another example. Some more examples in terms of cosine function. So I'm going to push this up a little bit in order to get room to do example. How about if we have y equals cos to the power of 3 4x. This is a good example too. So we apply here chain rule. And the reason we're applying chain rule, and let me rewrite it again in this form, to the power of 3. Everything is to the power of 3 the same way. So we just changed the face of the question for you to see that we're applying chain rule, because we go from outside to inside. And don't forget also that we must take the derivative of theta too, not just the trigonometric function. So to apply chain rule, we'll go from outside. So the 3 times the coefficient of the bracket would be 3, and we subtract 1 from the exponent would be 2. So we have cos theta, and the derivative of, so we go now the derivative inside. That's what chain rule is, from outside to inside. So the derivative of cos theta, we noticed earlier that it's negative sine theta, and theta is for x. Now, what is the derivative of theta itself? Don't forget, it would be 4. So we go from outside to inside in terms of trigonometric functions, because we have to also take the derivative of theta. Now, in order to simplify, so we multiply 3 times -1 times 4, it would be -12, and then we have cos 4x to the power of 2, so cos squared theta, basically. That's what to the exponent means, cos squared theta. And then we have sine theta, and that is in simplest form. So this is another example which also clarifies some of the examples that you might do from the textbook. So earlier video we did the trigonometric, the derivative of sine function. Now we did the derivative of cosine function, and our next video clip will be about the derivative of tan function. All right, so we leave it as this. Please practice a few times and more examples in order to understand really well. And you already know the reasons why the derivative of cos theta is negative sine theta. So please don't forget to subscribe, and if you have any question, there's a comment box below. Write your comment or question. I should be able to answer it. Till then, wish you all the best and good luck.